Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In this episode of our Strata Data conference series, we're joined by Justin Norman, Director of Research and Data Science Services at Cloudera Fast Forward Labs. Fast Forward Labs was an applied AI research firm and consultancy founded by Hilary Mason, whose TWiML Talk episode remains an all-time fan favorite. My chat with Justin took place on the one-year anniversary of Fast Forward Labs' acquisition by Cloudera, so we start with a bit of an update before diving into a look at some of their recent and upcoming research projects. Specifically, we discussed their recent report on multitask learning and their upcoming research into federated machine learning. To learn more about Cloudera and CFFL, visit Cloudera's Machine Learning Resource Center at cloudera.com/ml. A huge thanks to them for sponsoring this series. Thanks also to our second sponsor, Capital One. At the NIPS conference in Montreal this December, they'll be co-hosting a workshop focused on challenges and opportunities for AI in financial services and the impact of fairness, explainability, accuracy, and privacy. The call for papers is open now through October 25th. For more information or submissions, visit twimlai.com/C1NIPS. If you love this show, you've got to love our sponsors because they help make it possible. So please take a look at what they're up to and tell them TWiML sent you. And now, on to the show. All right, everyone. I am here in New York City at the Strata conference, and I'm seated with Justin Norman. Justin is the Director of Research and Data Science Services at Cloudera Fast Forward Labs. Justin, welcome to This Week in Machine Learning and AI.
Thank you very much. Glad to be here.
Awesome. So, Justin, you started your career in data as an officer with the U.S. Marine Corps. Tell us a little bit about your background.
Yeah, that's absolutely right. So I actually got a chance to study computer science and a focus on mathematical optimization at the Naval Academy. So naturally, when I made the decision to join the Marine Corps, I was asked to go into a technical role pretty much straight off the bat, which was just fine by me. But over the course of about 7 years, I got a chance to, both locally and also overseas, participate in a lot of large-scale network enterprises, which had massive data challenges. Not the least of which were that there at times were over 30,000 connected devices under management. And just understanding what traffic flows looked like, which were normal, what traffic looks like that were anomalous, and being able to react dynamically to that was a large portion of my job. So machine learning was embedded, quite frankly, in the sort of soul of what we were doing. But at the time, we didn't really have terminology for data science and machine learning. We just sort of did what we needed to do. But naturally, that helped me to sort of progress into industry as the field emerged a bit farther later in my lifetime.
You went on to found a startup in machine learning, is that right?
I did. So I worked with a few people that I knew quite well to try to work on the problem of business predictive analytics within sports. And so we weren't so focused on sort of the sabermetrics that you see from the sort of traditional sports analytics, but we're a lot more interested in trying to find ways to solve some of the corporate challenges that we saw in a lot of other industries, but applying them to industries which really didn't have that kind of background and skill set, and helping them to accelerate from a financial perspective. So a lot of our focus was actually in the beautiful game, in football, but the right football. And we did a lot of work in Central and South America to help some of those smaller clubs actually be able to take advantage of the business value of their players. For example, transferring or trading a player that had a higher social media impact than perhaps another player that was equally skilled, to try to impact things like ticket sales and retention of season ticket holders, things like that.
Interesting. I did an interview with a guy named Noah Gift that was doing some very similar things in terms of looking at how to score player social media impact and the ultimate impact on the game. So You went on to, among other things, do data science at Cisco.
That's right.
And now at Cloudera Fast Forward Labs. Tell us a little bit about your role and your focus at CFFL.
Great. Yeah. So as people may or may not be aware, we're actually exactly at 1 year of the acquisition of Fast Forward Labs at Cloudera. So in a nutshell, my role is to take Fast Forward Labs kind of from where it is, which is actually very well integrated and quite successful with its existing clients and some additional Cloudera clients, and really scale that globally. And I mean that from not just a physical standpoint. So yes, we want to expand to EMEA and into Asia, but actually also from a data perspective. So can we take the research that we've done, the products that we've developed, and start to do those at scale and the enterprise, and be really known as not just leaders in the research field, but leaders in how to apply that research across both corporate, organizational, governmental entities. That is from a technical perspective a challenge, but also from a human and strategic perspective a challenge, which is why I think Fast Forward Labs is really uniquely positioned. Because as you know, our research doesn't just focus on the technical and technique aspect of things, though we have quite a bit of research in that area, but also in how to layer the people and process and skills conversations into the application of that technology, so that you get the outcome when you actually expect to have it.
And so for those that don't know, the research that you're referring to is a series of reports. Can you talk a little bit about some of the topics that you've covered in the reports, just as context?
Sure. So the best way I think to talk about the reports is to start with a process that we go through to actually decide what we're going to do. And I think it's really powerful. So the entire team gets together and really calls out, I'd say with the intent to find some bad ideas of types of topics that might be relevant within the next 12 to 24 months within machine learning. And the intent is that we're going to look at topics that are not just papers or research that is out there in scholarly journals, but actually something that is starting to be applied in industry, or maybe we have the ability to bring that last step. And so topics in the past like natural language generation, semantic recommendations, image analysis with deep learning, and then most recently multitask learning have sort of become the topic that we've narrowed down in that process, and really have felt that is most relevant to the widest group of consumers that exists within industry, academia, and beyond. So we've actually just launched a report, as I just referred to, called Multitask Learning, which focuses on actually executing multiple machine learning tasks at the same time. And so we're really excited about that. And there's actually a number of people this week at Strata who are going to be speaking about that in greater depth. And so very excited to hear what they have to say about that. But we're not stopping, and actually have 2 more reports in the queue. And one of them we actually know what the research is going to be focused on, and that's on federated learning as well. So we're really excited to be able to share this, because we think that now we're becoming influenced not just by the community that we had through Fast Forward Labs, which was extensive, but also because we're at Cloudera, we now have a focus along the enterprise with a much, much larger scale that's helping us to understand what's relevant to that community as well. And that definitely has directly influenced what we've been able to perform in the research space as well.
On that multitask learning paper, I haven't had a chance to take a look at that one, but around the time it was that initiative was being kicked off, someone at CFFL reached out to me to see if I knew anyone who was working in that space. And I had recently done an interview with Ryan Poplin at Google. I'm pretty sure that's who it was, who had made an interesting comment that they were looking at these retinal fundus images and using those to determine a variety of demographic information about the people who the images came from. And they noticed that when they asked their model to determine a single thing and compare the performance relative to asking the model to do multiple things, the model performed better when it had multiple things to do. And his theory was that kind of forced the model to generalize better. And so I kind of made the connection. I hope that connection
it's a good connection.
Useful.
That's a very good connection, and I think you'll see that in the report. Even that we recreated results not on that specific use case, but on other use cases that was very similar. And in some areas, it's very well explainable to your point why that happens, and in some areas it's not. And I think that's one of the most powerful parts of the research component of what that report covers. So you certainly can recreate that experience where you do have model performance that's a bit better on one or multiple, multiple or even 3 or 4 or even more learning tasks at the same time. But the type of data is highly relevant to whether or not you're going to see that performance, and that's one of the things that we spend a lot of time talking about.
And so what's the kind of core thesis of that paper?
So that for, like I said, for certain types of data sets and for certain learning tasks, you should definitely do it.
Okay.
So it is the core thesis. But I think the most important part is that it is possible to actually execute these multiple learning tasks, and execute them at scale, utilizing some of the more now commoditizable learning functions. So things like deep learning models are highly relevant to this as well. So the focus is on really making sure that people understand which techniques exist and then when to apply them.
And are there a specific set of techniques for multitask learning, or is it just the same stuff but with multiple objectives?
They're a little bit of both.
Okay.
So there are definitely certain sets of techniques, but it depends on the objective.
Can you give me an overview of the specific types of techniques?
That what you would need Federated for.
Okay. That was the report that recently came out. Going forward, you are looking at, you mentioned that the next one is going to be on federated learning.
That's right.
What's the thinking around that?
So one of the things that was always a theme at Fast Forward Labs, and I think, again, back to my earlier point, is something that's coming front of mind because of the types of customers that we've been working with at Cloudera, is the idea of really trying to execute and scale machine learning at the edge. So by the edge, I mean at devices that are the last device before a human or last device before a sensor executes its function to read data from an environment. And there's a number of reasons to want to do machine learning at the edge. But I think one of the biggest ones is if the device, and now they do, have enough computational power to execute that, you get results back that you can influence outcomes with directly without having to report back to some kind of central model or some kind of central computing store. So this is most relevant in IoT applications. I think you can even think of it as a human with your cell phone. There's obviously multiple machine learning models that are powering very important functions on your phone. But one of the challenges that comes into play right away with that is that ultimately there's a lot of people who want to have the power of machine learning and AI enabled capabilities, but without necessarily exposing the underlying data structure. And the data that data structure that might be influenced by a person's personal choices, for example, in a commercial application, competitor IP applications that don't want to be shared with the industry. But you still want the benefit of being able to train and to share, for example, parameters or hyperparameters settings that are relevant across the scope of problems without necessarily exposing how you got there. And so federated learning is a set of techniques or an approach to be able to do just that, where you are potentially have a centralized model or a model that serves as a baseline for one or multiple devices that are deployed over multiple workflows, but you still get a chance to benefit from that without exposing each one of the individual data, underlying data structures that are there. And that's very important from an ethical perspective, very important from a commercial perspective. And also it does have a performance impact, a positive performance impact. As you might know, you're essentially starting from, a little bit farther down the race instead of at that starting line.
So is the issue that you're kind of framing around not wanting to disclose model parameters is the issue that you're looking to address the idea that if you push a model out to the edge, you're exposing that model, the parameters of that model are IP, and you're exposing that IP?
Kind of the other way around. It's the data we don't want to expose.
Okay.
So, for example, if you're using a phone, the types of text messages or images that you have on your phone are very private. You don't want that to be shared. But being able to do natural language processing or analysis of your text messages in order to respond better, provide applications on top of that is something, of course, you want to have happen.
Right.
So if you are a provider of software, of mobile software, you want to be able to train models on the widest set of information you possibly can. But you may not have the benefit of reading everybody's text messages, nor should you. So is there a way that potentially that you can get the benefit of a more precise model that fits better to a larger set of data, generalizes to a larger set of data, without actually having access to that data? And so being able to perform these multiple learning functions over time and a very broad set of workers or workflows that are existing in near real time, and then giving that information back, the potential parameter settings of a model, or the sort of things that shape a fit to have a model be more generalizable without exposing the underlying data is what we're looking for.
And so the idea is that I've got access to some set of data at the edge. I don't want to send all of that data back to some central location, either for privacy reasons, bandwidth reasons, whatever, all of the above. So what can I do on the edge to presumably, we talk a lot about the edge for inference, but what we're talking about here is to train or partially train on the edge, and then use that to, it sounds like the idea of Federated is use that to enhance a centralized model that can maybe even be like distributed, or some aspect of that model or what that model's learned distribute out to the other edge devices.
There you go. Perfect.
How do you do that?
Well, I mean, you'll have to wait for the report. But the long and short of it is, it's now possible from a computational perspective to execute these multiple workers. When you're thinking about a model that's being deployed anywhere, it's being done by some automation workflow, just like any other software engineering component. And so now that we can do this, not just like with one or two on a laptop, but with 1,000, 5,000, 100,000. And actually have not just a bit, like we don't have bandwidth constraints, but also not computational constraints. That's a large part of what we'll be exposing as, hey, how to actually execute this, and then what are some of the constraints of that from a technology perspective. That's one aspect of it, and then from a sharing of model parameter information or model fit information, how actually to bring that back to a centralized location to average and generalize that across the full scheme so that it's useful to be, to your point, distributed back into that matrix of learners is also what we're focused on. So there are a couple of techniques that we've developed and a few that we've adopted and written about that you'll hear about very soon.
In the past, my impression of the reports has been that the focus is on kind of going out, exploring what's out there in important areas, and writing about those. Like one of my favorites was the natural language summarization one, right? And it did kind of a survey of all the different techniques that have been used to do summarization, LDA, a bunch of other things. It sounds like here you're starting to tiptoe into developing some technology or algorithms?
Yeah, and I think that happened largely because we recognize that this is a really important need for industry and for government. But the techniques that we did research on weren't as mature as they might have been for other areas of research that we've explored. So if they were out there, we'd certainly tell you that these are the ones you should use. And I think we've taken a good survey of what we found for Federated Learning. But this time around, it became necessary for us to bridge the gap a little bit. And so, of course, the team has that capability and is more than happy to do that when we think it's relevant.
I mean, in a lot of ways, that is, it kind of pokes at the thesis of the research, which is, I've always interpreted it as, this is stuff that's like right at the edge, and hey, this cool thing happened someplace which kind of flipped it and people don't really know yet.
Right.
I'm trying to remember what the thing was in the summarization paper, but there was some new, I think it was word vectors, right? So there's a bunch of LDA stuff and language modeling that, people were using for this, and it kind of worked a little bit, but it wasn't great. But hey, word vectors came around, and now we can really do interesting summarization stuff. The thesis was, hey, we're kind of scanning the world looking for
these opportunities where external change has enabled some new way of some new capability. Here you're kind of more being that external change.
Yeah,
it strikes me as a pretty significant shift.
It is a significant shift, and I think it goes back to how we started the podcast, which is Cloudera gives us a platform now to have I think a perspective on what's happening in industry from the top layer, right? Mm-hmm. So I think one of the things that's very powerful that we've maintained about Fast Forward Labs is that we're talking to academia, we're talking to startups, we're talking to organizations which are focused on machine learning and AI. And that's a particularly powerful perspective that we've always had, but we didn't have as much exposure to the industry players, the people who are doing machine learning and AI at scale on the edge in the petabyte scale, right? So I think what we're finding now is we're being asked by that community to solve a different set of problems, and those problems may not have been commoditized yet. So we have the ability to connect what they're looking at strategically and from a business or a mission relevance perspective, and then apply that cutting edge research, which was always sort of there, with a layer of interface, to use a word. So I think that's what's occurring as a result of that 1 year being at the company.
Okay, interesting. And now this whole area of devices and the edge is not new to you.
No.
We didn't talk about it in your background, but you spent some time at Fitbit.
I did.
How has that informed your thinking about this whole space?
It definitely has been shaped my thinking about this space, and made it, quite frankly, top of mind for me anytime that I recommend building a model factory, an AI system. And to just get a little bit deeper about that, at companies that have an edge device that's being delivered to a consumer, or is being used to gather information from the environment like a sensor, you end up having this really poignant real-time challenge. And so you need to, and you want to do machine learning right at that device or near that device, because it's important to be able to serve back either to your human or to the environment the results of a model or the score of a model in some very poignant way. And the example that you get on a device like a fitness tracker is that a person might go through some fitness activity and want to see projections of where they might be had certain variables changed. Had they run faster? What their heart rate might be if they were to continue the next set of their exercise. For example, something very famously, the number of steps that you're doing, that's not a static number for any human being, and their performance upwards or downwards on that, depends on a variety of factors, a variety of features, to use the machine learning language. So, of course, you want to be able to provide that back as quickly as possible, and the latency incurred by going back to a more robust offline data store sometimes is just not performant enough to provide that. And so you end up wanting to do this sort of challenging activity, which is to do training of a model and batch scoring of a model within your data store, where all of the data actually lives on a larger platform, like, for example, Hadoop. And you want to be able to somehow take the results of that trained model and put it somewhere that's much closer to the user itself, which is probably near to some connected device at the edge. And it actually means that you need a couple of different environments to be able to do a scoring of machine learning models or AI models. And then your production environment doesn't become something that's running within 24 hours of latency, but something that may be running several times a minute or even a second.
When you say a couple of different environments, what do you mean?
I mean deployment environments for machine learning models. So, for example, historically, deployment might look something like, I have a machine learning model that's written in Python, and I'm going to use a cron job or something like that to schedule a run of the model. It'll just pull a representative sample from some interface layer on top of Hadoop, and then I'll return the results of that and dump it in a table somewhere else, also in Hadoop, and then people can query that with whatever they want. Let's say SQL, right? So that's a deployment workflow. And then if you want, from an application perspective, to return results you could put some kind of RESTful API layer on top of that, and then you listen to that endpoint or hit that endpoint whenever you have a request. That's an idea. Not super performant, right?
Yeah.
So imagine if I was a cell phone or a fitness tracker, and there were 17 million of me,
Right.
and I wanted to do that same function. I was querying that API directly from there. It's pretty challenging, right? So you actually end up needing a different environment, actually a completely different software engineering workflow to deliver that kind of performance. But you still want access to the underlying data because it's still sitting in Hadoop, and that's how you train. Right, so this is sort of an extension of the problem that we were talking about before, where you actually do want to have access to the data, and so having a separate environment that's closer to the consumer, whether that be a device or a person, allows you to actually do some pre-processing and pre-training of features actually at the edge or near the edge. And so for that common set of information or features that are going to power these models, you end up wanting to do that pre-processing almost as the data is streamed itself, right? And then allow the model that's sitting on that device to pull from that source of data where it needs to, and then return results much more quickly. So that's one of the things that I learned while working at a device company, is that sometimes the machine learning challenges are not necessarily from a technique or algorithm perspective, but actually how you apply it. And how you apply it to get the outcome that you're looking for from a consumer perspective, in sometimes near real time or sub-second time.
It sounds like when you describe this architecture, and the different environments, we've talked about kind of the central capability, we've talked about the edge, but it almost sounds like you're laying out a hierarchical environment where you've got, maybe you've got regions and something that's, immediately behind the edge, like. This is talked about often in an IoT environment. Sure. You've got your edge devices, and then you've got your plant device. Right. That's kind of a, I don't know that it's clear what the exact function of that is today. It's kind of doing some training and intermediate model development, or at least that's the, people aspire to that.
Sure.
Today it's more doing data collection.
That's
and then centralizing the data, transfer it to, some mothership or some kind of intermediate mothership. How do you see all that evolving?
Yeah, so what I think is starting to happen is, because there's a much clearer definition of what actually you're going to need, especially for commoditized models. So if we're talking about like ensemble models, like Random Forest or XGBoost, we know, we're very, very good at understanding what these models are going to need from an input layer perspective to be successful, right? So when you begin to pre-process or pre-train features or pre-train data, and put that closer to the edge, the intermediary that you're talking about actually can be responsible for promoting these feature sets, and accomplishing this migration of data with the very precise scale, as opposed to just dumping or translating everything when we think we might need it. And I think that's where ML ops or AI ops is actually going to start to take a bigger role. And really even applying machine learning to the workflow itself and what necessarily needs to be accomplished during that phase, and you start to see the technologies like Airflow and Jenkins be the control layer for it, but underlying it, there's actually a machine learning functions that are powering what we translate into the online feature store, which I think is something that's really exciting.
Now Airflow is kind of a data workflow open source project developed by Airbnb.
Airbnb, right? I think the original developer came from Facebook and then worked at Airbnb.
Okay.
But yeah, so Airflow is an example of what I'd call an AI DevOps or an AI ops tool. It definitely does scheduling and workflow management, just like any other tool like in that category would do. But I think what makes it specific is that it's really tuned for the types of techniques that you'll need to perform in a machine learning workflow specifically. And so I think that category of tools is starting to become not just needed, but also appear in multiple software options, which shows that it's validated in the market. And Airflow is an open source approach to it, but there are certainly a lot of others who are taking a more commercial approach to it, and I think it's going to be necessary, and as a lot of these companies and projects scale.
And you've mentioned Jenkins, which has been around forever, kind of in the Java community for doing builds and stuff like that. How does that fit into this whole
Well, I think we're like getting into the idea of how we're going to, or what is a model, or what is a deployed model. Right?
Yeah.
And so, a deployed model, as we mentioned before, could be simply a table somewhere that we've scored, or we've used a function to score, some model to score data, the results of data, and put it into a table. That could be, what we consider deployed. But I think more and more we're starting to see deployed mean it is the model architecture itself, and the ability to query that model architecture for the result that we're looking for in some kind of performant or way that we can fit into an SLA. I think that's what we're starting to see. And so when containerization and microservices are layered together to try to produce this result holistically. So like, a model, becomes the container itself, and the services that it takes to be able to interface with it. Tools like that, automation and workflow management tools become critical, because when you're actually interfacing with a model, you actually might be spinning the whole workflow of a machine, the data workflow that the machine needs to interact with, and then performing the scoring, and then actually returning that result all at once. And so it's no longer about just having the skill set to be able to produce a nicely fitted model against some set of data. It's actually being able to return that result in the way that it needs to be consumed, either by an API or directly to an application. And so now we're in this space where we're thinking about things a bit more holistically, and we have to.
Maybe going back a little bit to this kind of federated model, federated idea. I'm just kind of in the back of my head thinking through like how this might work. And at one thought is at a low level, people are doing things around distributed training, and that's all centered or frequently centered around this idea of like exchanging gradient updates from one machine to another, or having something that's tracking all of these gradient updates that the distributed workers involved in training can access. Like, is that part of what we're talking about, or are we talking about, when you talk about federated training and federated ML, is it something at a higher level?
Well, so I think it's certainly a component of what we're talking about, but I think we have to be really careful there not to slip into the space of training the model, of leaking essentially across, and that's exactly what we don't want to accomplish with federated. So I think
and elaborate on what you mean by that.
So the idea of even though individual workers or individual models that are being deployed by workers don't have access directly to other data stores, the fact that they could learn the underlying patterns or structures and perhaps infer what's there, we really have to be careful about that. And so the idea of federated sort of abstracts, I think, a little bit more. How to accomplish that, though we're sharing, not just gradient information, but really a larger set of parameters that are available depending on the type of model. And actually, because it's much more oriented around the techniques, the specific algorithms that we're using underneath that shouldn't matter as much. But rather, it is the mechanism for which these distributed workers are able to share to a centralized repository, and then that centralized repository performs better than in each individual one could do, that we're really focused on.
So then it sounds like it is operating at a higher level, yes. And the goal is less about sharing these gradient updates or whatever is a low level kind of information sharing for the model in question, to allow a distributed model to converge, and more like training a model individually at different places and sending key information about that model, sharing key information about that model to make everyone's models better.
Right. And so again, the sort of central idea, if you were asked to summarize that, would be that, if you have, the ability to take advantage of these techniques, which might be, ultimately computationally expensive to do across such a large set of independent workers, you would achieve an outcome which would be impossible without that centralized sharing of information, without that federated sharing of information.
So the other thing that this makes me think a little bit about is differential privacy. Is that something that you've looked at previously in other roles, or that you are looking at in the context of of this federated learning
Yeah,
project?
definitely. I think we're gonna definitely try to write about that. But the research is ongoing, so I wouldn't be able to tell you what we've uncovered yet because we're literally looking at some of these things right now.
Okay. You talked a little bit about online versus offline learning. Often when the whole online learning comes up, it comes up in the context of Spark and
Yeah.
streaming and pipelines. How do you see that fitting into this?
Yeah. So when I was describing the scenario earlier, where you might want to respond to an activity or something that has occurred, like for example with a fitness tracker, those exchanges of data are happening with real time streams. So I don't think it's a secret to anyone that that Spark streaming and really things like Kafka interfaces between these devices are a key component of how this works. So what I would say is that's the piping behind this process is that we've been talking about. What makes it a little bit more challenging is the sort of potentially asynchronous nature of how data works in that area, and this is back to the sort of Cisco days, and the for lack of a better term, the UDP-ness of it, where you may receive some or all of the data, some of it may be out of order. Probably will be. And you still have to find a way to coherently respond to that. And I think that component of it becomes a data engineering challenge, which is at the edge, combined with a machine learning challenge, which is at the edge, combined with a software engineering challenge that's at the edge. And so we have to solve all these problems very, very quickly. And so what I've seen in industry so far as I've worked on it is that everyone's architecting slightly different workflows around this. And it's probably time that we and others begin to standardize that a bit to make it more accessible for the community.
And so we're specifically talking about workflows. Are you talking about the federated concept specifically, or we're not? We're talking about kind of the workflows for managing these edge devices and doing software engineering for edge devices and
I mean, you asked about how streaming plays into it, and I think like I said before, it's the piping that regardless of what application you're trying, whether it's a federated learning mechanism or simply you're just trying to deliver online services, machine learning services, you're going to have to interact with that environment, and the ecosystem right now is pretty complex, and I think we've got to do some work to at least abstract some of it so that we're much more focused on solving the problem than dealing with engineering workflows, which is where we currently are.
And how close do you think we are to being able to do that? We've advanced engineering practices, with DevOps, for example, significantly over the past few years. And we've got a growing base of experience with mobile. Although from the device perspective, the rate of change of what's happening on the device tends to be a lot slower than what we'd want in a kind of an IoT enterprise, more agile environment. But with those as kind of background, then we got these two, IoT, which is changing quickly and we're just kind of wrapping our heads around and trying to figure out, and then to layer onto that the machine learning and AI stuff. Like, how do you think we as an industry put together? You mentioned standards. It seems like we're so far from standards, just a way that works that consistently to manage all of this stuff.
It's a hard problem. I'm not going to trivialize the problem. I don't think that is that would be a smart thing to do. But I will say that it might be useful for us to maybe go a little bit away from segregating ourselves by community. There are very well understood, very powerful practices and networks that have existed for years that might be really helpful for us in some of these challenges. They've been dealing with real-time streaming since the beginning of computers sharing information with each other, right? I spent a lot of time at Cisco, and let me tell you, there's some people there who have gotten down to the algorithm level on Dijkstra's shortest path and can tell you exactly how messages respond to that, from device to device when you're talking about the context of a router. And those standards exist. They're actually they're very well documented. They're published. They're public. So I think that we have examples of how to accomplish this, sort of standards-based practice out there, but it may not come from the community we're familiar with. Right. So as a machine learning practitioner or a data scientist, you're probably a lot more familiar with the software engineering community. And you're probably a lot more familiar with people who are publishing standards by way of GitHub, or standards by way of library. But we may not have access to, or may not have thought about applications for handling messaging or handling workflows. Even a lower layer of the stack in the computing. And I think it's going to be this interface of communities that are happening that helps us to build out these standards and practices that make sense, because we are not talking about one community. We just talked in this conversation about multiple different architectures converging. So I think we need to expand our view a little bit and start to look for places and people that have experiences, potentially in a different part of the stack that can help us be successful where we are here in the real-time and online ML conversation.
You talked about Spark as being core to this streaming environment. Is there an analogous environment or platform on the Python side that's gained any traction?
Yeah, not that I'm aware of. And I think largely that's happening because of the way that Python tends to interact with data in general. I think as data scientists, we've tended, and this might just be a community issue, we've tended to use it on the research and dev side. And so interacting with data, at the less abstracted layer, really at that point has not been something I've seen a lot of research poured into, but I could be wrong about that. So, I think I haven't seen it, but, that's not to say it doesn't exist.
Right. So you mentioned the term AI ops, or you might have said ML ops a couple of times. I've done some writing about that term, but as applied to AI-enabled IT operations,
Sure.
So like managing the data center with AI, Sure. Are you starting to see, or are you starting to evangelize the use of that term to specifically refer to ops as it relates to AI, meaning managing the AI infrastructure of an organization?
Yeah, so I think that's where I would hope it would go. I mean, who knows what these terminologies are going to end up? But I mean, we're talking about AI when 10 years ago we've been talking about applied statistics. So it could go anywhere. But I do think that that's a really powerful way to use that term, because I think in a lot of ways, I actually saw a tweet the other day that was really, really great. That was talking about asking software engineers and IT people to deploy models being just like, trying to have SeaWorld take care of your giraffes just because they take care of other large scale mammals, right? Like it's really a completely different set of skills, right? And so when we think about software engineering, we have a terminology, we have a framework, we actually have tools, an entire category of software that's devoted to taking care of the operations necessary to manage the software infrastructure that runs a company, right? It's a huge business, and it's actually really important. But from an AI perspective, historically, and I've experienced this personally, you're usually either asked to do it yourself, or you're translating or giving your baby, so to speak, to IT or an engineering organization and telling them to scale that. And what almost universally happens is they have no idea why you made those decisions. They disagree with them, sometimes for really good reason, about the way that you approach it from a software engineering perspective. And so they re-engineer the whole thing and miss a lot of the core components of what you were trying to accomplish in the first place.
Can you give a specific example of that?
Yeah, so I can tell you that one of the first models that I actually developed myself in industry, was written in R. I think like a lot of us were doing it. It was a simple logistic regression, returned a binary result. And I felt like it is quite generalizable for the problems that we're looking at. So I delivered it to my IT organization to be applied back into one of the products that was actually already online for one of our internal tools. And they rewrote the entire thing in Java. And so the challenge with that was, Java has a lot of, it's very verbose.
Right.
And so the performance that I had sort of expected out of my small, lightweight, 7-line Python code now had a whole bunch of other dependencies that I'd never planned for. And so the application, the AI application, so to speak, that returned sub-second or very close to a second results for the data set size I was looking at, and now took 5 to 10 minutes to run.
Usually we think of going from R or Python to Java as a step forward in performance, right?
Totally. If only that's all you're doing, but in the context of it being run in a much more robust application, which had quite a few other dependencies that I never cared about, that isn't necessarily the case. And so, I think if we'd had a much more robust AI workflow in place, I would be deploying my model, so to speak, and the workflow or even the AI toolkit itself would decide the best way to implement that or to return that, rather than the IT organization and myself having to have the negotiation for every single product that we develop, right? And so that you see that all the time when someone checks in code, to a DevOps workflow. They have no idea how it may be integrated at the end. It doesn't matter. It's that the core component of what the application that they developed gets integrated into the overall. And so we just got to get there from an AI ops perspective.
And I think we're starting to make a lot of progress on that. Years ago, maybe 5 years ago, let's say, we would talk about data scientists as this unicorn that did everything, right? And now more often than not, we're starting to see, specifically in internet companies, right? You've got this very well defined role now of machine learning engineer that tends to work hand in hand with data scientists. People are even changing, data scientist is becoming a bit passe, and now there's like applied research scientists and these other roles, but it's much more of a teaming kind of relationship between these two. And the ML engineer then inherits, because they are an engineer, they kind of inherit everything that's been developed, in terms of DevOps processes. And it seems to be that a lot of that is much smoother, for organizations that kind of have that worked out. Now, this tends to be internet companies, not enterprises. There's still a lot of work that needs to be done, I think, to kind of translate these practices.
That's right. But we're getting there, and I think you're right about that. This is a good story. I'm not here to sell doom and gloom. I think we're absolutely getting there. I would expand your list to data first companies that use information that they either generate or derive from their customers as the main product that they then present back to their consumers.
That's a great distinction, yeah.
And so there are many that are in that category, but the ride sharing companies, anyone that's doing consumer pricing, like hotel companies, come to mind as the ones they're really innovating in this area. It's a little slower for utility companies. It's a little slower for telecoms, and it's a little bit slower, for governments. And I think these are some of the organizations which actually have the data at the scale that we really want to interact with. And I haven't seen as much of that there, but we're on the way. And to your point, if we can get the tooling, ready or closer to being, being mature as we build those roles in those organizations, I think that's a really good marriage.
Yeah. Awesome. Well, Justin, thanks so much for taking the time to chat with us. It's been great to meet you. Welcome to CFFL. You're like 90 days in.
This is day 90. Yeah.
Awesome. Well, enjoy the rest of the conference, and thank you.
Thank you.
All right, everyone, that's our show for today. For more information on Justin or any of the topics we covered in this show, visit TWiMLAI.com/talk/185. For more information on the entire Strata Data series, visit TWiMLAI.com/StrataNY2018. Once again, a big thanks to our sponsors, Cloudera and Capital One, for their sponsorship of this series. As always, thanks so much for listening, and catch you next time.